Hello and welcome to this introductory tutorial on AWR's Microwave Office Simulator. This is an extremely powerful tool which not only can be used for RF and microwave frequency simulations but also for AC and DC ones. So let us take a look at the main elements of the user interface. First and foremost, there are three main tabs that we have to be familiar with. First of all, the Project tab, which is the one currently shown. We will be talking a lot more about this in a moment. Then there's the Elements tab, and in the Elements tab you can pick circuit elements, for instance, which you can use in your schematics. These are grouped in different subcategories and are part of the AWR simulation suite. But also, and more importantly, if we scroll down, we can see that we can also access some libraries. In fact, the libraries which are available on the AWR website give you access to models, both linear and nonlinear, which are either supplied by the manufacturers of the devices themselves or by bespoke companies who carry out the characterization. We will see during our tutorials how it is very important to have realistic models for the devices and the components that we use in our circuits. We also have system blocks, which are the building blocks which we may want to use if we wish to carry out a system-level simulation. Lastly, we have the Layout tab. In this tab, we have all the information that we need to create an actual layout, an actual board layout from a schematic diagram. And this will contain information about the materials that we're using, the type of board, as well as the footprint of the devices, for instance. Let's go back to our Project tab. The first element in our Project tab is Design Notes. If we double click on this, you can see that a notepad-like window opens up. This is very useful because you can put notes about your design in this section, and this can be very helpful when you open a design after not having looked at it for a while and you remind yourself of specific choices that you made. And it can be also very useful when you're collaborating with other people and other engineers, and they may want to have some more information as well as the schematic and graphs on what you actually tried to achieve and how you achieved it. The next item is Project Options. This is extremely important and is the starting point for any simulation that you want to carry out. If we double click on it, we can see that we get a window which comprises of different tabs. First of all, the Frequency tab. The Frequency tab allows you to specify a single frequency or a range of frequencies which will be used throughout the project for all the simulations and all the graphs. So, for example, if you inserted a signal generator in your schematic, you wouldn't specify the frequency at which the signal generator operates directly in the schematic diagram. It would be determined by the frequency range or the single frequency which you've chosen in this tab. Now, a couple of things to point out. If we want to have a single frequency, we just type the frequency that we want in the start box, select single point, and then apply. And you can see that in the current range we can then see that one frequency point. Remember that you always have to click on Apply in order for the range to be updated. If you just click on OK, that won't happen. If we want to select a range, for instance, we could do 1 to 10 GHz in increments of 1, and then we have to select Replace and Apply. And you can see now that the range is appearing on the left-hand side of this tab. We can also select specific frequency points within the range that we've created and delete them from the range because we may not be interested in those specific points. For example, by pressing and holding the Control key and then clicking on specific points, for example the top and the bottom of the range, and then clicking on Delete Selected, I have narrowed my range down as shown. Also, for example, between 5 and 6 GHz we may want to have a bit of a finer frequency resolution. In that case, we can just select 5 as a start, 6 as an endpoint, and say a step of 0.1 GHz, and then we can select Add and Apply. And now you can see that we've got the range that was there before, but between 5 and 6 GHz we've added a number of points, and this will give us a finer resolution. So it's important to know how to use this tab because it can be extremely versatile and useful to the designers. The other project options tab that's very important, and we would be using this pretty much every time we start a new simulation file, is global units. So if I just click on global units, you can see that you can select pretty much any of the units in the circuit. The frequency, for instance, at this moment is specified as being in megahertz, but you could select gigahertz or whatever other units you find suitable. The resistance is in ohms, and that usually works fine. The conductance often enough will change to millisiemens. This, as we will see in future tutorials, seems to be the most suitable unit for radio frequency components. The inductance in nanohenries tends to work. The capacitance in microfarads is a little bit high. We will most of the time be using capacitance in picofarads. I always use metric units, so I encourage you to do so as well, and millimeters is the best way to go for most of the applications that we will be looking at. So we can then click on OK, and then move on to the next item. The next item is global definitions. Now, global definitions, if we double click on them, basically give you a canvas when you can specify the global variables for your simulation. And this can be very useful, for instance, for a specific substrate of a specific height and dielectric constant. If you want to use 50 ohm lines throughout your design, then you will use the same width for your microstrip lines throughout the whole circuit. And so instead of typing in the number for the width of each microstrip line that you will be using, you can just set a global variable into global definitions, which you can then use throughout the simulation. And also, if you then change that specific width, because, for instance, you've decided to design on a different substrate, then it's very easy to change the width for that specific transmission line throughout the simulation in one stroke. Next, we've got data files. Data files can be files that you get from your network analyzer, for instance, S-parameter files. They may be S-parameter files that the manufacturer has given for a specific device. And it's quite easy to import them. You just right-click and go onto Import Data File, and you can basically get any type of S-parameter file imported. The other thing that you can do, however, is to have a new data file. Then you can write in the S parameters yourself. And this can be very useful, and we will see this specifically in one of our tutorials. When, for example, you're getting your S parameters from a book, you see an exercise and you want to check it out with a simulator. You've got the S parameters there on a hard copy, and you want to put them into the simulator. You can just create a little file yourself with the S parameters. The other thing that you can do, if you have a data sheet with a list of S parameters, you can just cut and paste those S parameters from the PDF file into the text file here, save it with the right extension, and you've made the S parameters from the data sheet directly usable in the simulator. Next, we got system diagrams. Now, we won't be looking at this in our tutorials, but what you can do with Microwave Office, provided that you have a license for VSS, is to carry out a system level simulation. You can insert system blocks, which may come from your own circuit schematics or elsewhere, and you can carry out a full system simulation. For instance, you could have the whole uplink or downlink of a transceiver set up, and you could put a specific modulated signal in the input and see what comes out of the antenna, or you could have a signal coming in from your antenna and you want to see what comes out at the end of your receiver. You can do all these sort of things with VSS, but we won't be going through that ourselves. Next, and this is probably the one that we will be using most of the time, is circuit schematics. This allows you to create new schematics. And once you've got your schematic set up, you can add various elements and put together the circuit that you intend to simulate. It is very easy to open a new schematic. You just right-click. Remember that this simulator has got a Windows-based interface, so right-clicking usually helps you a great deal. So we can select New Schematic and then click on Create. Now you've got the schematic there, it's obviously empty. And what you can do is, for example, go to the Elements tab, and then you can find whatever element you're interested in. For example, we can go onto the microstrip lines, find a line, for instance an open circuited microstrip line, and we can just click on it and drag it onto the schematic, and then click again to place it. The other way to place elements on a schematic is pressing Ctrl L from the schematic window, and then a window opens up which allows you to search for a specific element. Now, if I know the name of the element that I want, then you can just type it in and the element should just come up, so you don't have to go and browse through the element tab. For example, if I want a DC voltage source, I can type in DCVS. Of course, I know that this is what it's called, and then I can just double click on it and then place it on the schematic like so. The other thing that you can do when you open the search window by pressing Ctrl L is actually search for the description of an item, because it may so happen that you don't know what the actual name in Microwave Office is, but you know you want a DC voltage source. As you can see, there is a suggestion at the top of the window that says Control click the column header to change the column to filter on. So if you just press and hold the Control key and then you click on the description heading, you can see that the little funnel symbol has moved from the name column to the description column. Now I can just write DC voltage source here and I can get my DC voltage source. I could change DC to AC, for instance, and again I get what I'm looking for. Or, for example, I may want to have a pulsed voltage source, so just put pulse voltage source, and there you go, you basically get what you're looking for from the description. However, when you know the name of the element, it's much easier to just keep the name as the column to filter on. So we can change back to that by pressing and holding the Control key and then clicking on the name of the column heading that you will want. So you can see the funnel now is back on the name heading. So now if I wanted a pulse voltage source, I'd have to go for V_PLS, and I would find it by the specific name that Microwave Office assigns to it. Next, we've got netlists. Netlists are specific types of files that come from legacy simulators, for example HSpice, and they can be very useful. In netlist format you can find nonlinear models for transistors, for instance, or for diodes. So it is important to know that you can import this type of file into Microwave Office quite easily, and again you just right click and select Import Netlist, and this will allow you to import an HSpice file, for instance, which again may be provided by a manufacturer, and then use it in the simulator. The next item is EM structures. Now, we won't be going through EM structure into a great level of detail, but it is an incredibly powerful tool. Basically, what you can do once you've got your schematic ready and working is create an actual physical layout for that specific circuit and then simulate it using an electromagnetic simulator. In fact, Microwave Office gives you access to 3 different EM tools with different levels of accuracy and different capabilities, but those can really allow you to verify your design on an EM level, and this is a very useful thing to have within a simulator, particularly in this platform where it is extremely easy to go from a schematic work into an actual physical layout and an EM simulation. Next, we've got output equations, but before going on to that, I'll actually talk about graphs. Graphs are the tool that you use to be able to display the simulation results. If you don't set up any graphs, the simulation actually won't run, because Microwave Office only carries out the measurements that it needs to carry out, and those are the measurements specified by the graphs that you've set up. So you can set up any type of graph. If I right click and click on New Graph, you can see that you've got all sorts of types: rectangular, Smith chart, polar plots, and even 3D plots. So it is very powerful, and we will be using different types of graphs throughout the tutorials. However, sometimes what you may want to do is to get a specific result from a simulation, but you want to store it in some variable, so it is in numerical form rather than graphical form. And this way you're then able to manipulate the results that you got in numerical form and perhaps derive other equations or other measurements from the actual simulation result. This is done by using output equations. So in output equations, you get a very similar choice of measurements, but instead of the measurement being displayed on a graph, the actual measurement is stored in a variable or in an array, and then you can work with that variable to carry out the various manipulations that you may want to do. Next, we've got optimizer goals. I believe that most of you will be familiar with optimization. Basically, what you do with this is once you've got close to your design goals, you can just use the optimizer to get closer or get a better match to the specifications that you've been given. And there are various techniques that can be used, and we will be looking at this in subsequent tutorials. Next, we've got yield goals. Now, this is a much underutilized yet incredibly useful tool. You know, of course, that when you put real elements in a schematic, you will have some tolerances, for example, on the value of capacitance and inductance, but also on the dimensions of your transmission lines. The fabrication processes can have different tolerances, so your line may end up being slightly longer or slightly wider or narrower than you've actually specified. Now, before you actually get your design into prototyping and production, you have to make sure that your design is not too sensitive to small changes in the values of your components or in the dimensions of the tracks on your board or other elements. This can be done with yield goals. You basically set up a range and a tolerance on each element in your schematic, and then this analysis allows you to see how many circuits out of a certain number will actually meet the specifications once they are produced, taking into account all the possible values that the components and the dimensions can assume within the ranges that you specified. Output files is quite obvious. You can actually store the simulation results into output files. Data sets are very useful to store results from specific graphs, and then you'll be able to recall them as and when you need them. We won't go into the next three items. They are a bit specialized, but what I'd like to talk about is wizards. If we just expand the wizard item here, you can see that there are a number of wizards which are available in Microwave Office. The one that we will be using is the iFilter wizard. This wizard allows you to design matching network in a very effective and efficient way, and you can select various topologies and see instantly what the frequency response of those topologies is and what the insertion loss is, for instance. So it's a very, very powerful tool, and of course you can use it to design any filter, but at the end of the day matching networks are indeed filters. The other one that I've personally used is the Lot Pool Wizard, which is used to design power amplifiers. Lastly, we've got the user folders, and you can copy any schematics or any graphs in here, and this can be very useful if you've achieved a specific goal and you want to store the data from that simulation, both the schematic and the graph, before you go on and maybe mess with it or try to improve it. So you've got it saved right there. Lastly, there is something that I would like to point out. As we mentioned at the beginning, once you've set up your frequency range in the project options, that frequency range is what will be used for all the simulations. There is a way around this, however. If you want to simulate for different frequencies for a specific circuit schematic, what you can do is right-click on the schematic and then select Options. And as you can see, under the Frequencies tab, you can either use the project defaults, or you can just untick this and then select a bespoke frequency range for that very schematic. Now, this can be really quite useful because you may have a number of schematics in your circuit, and it may so be that some of them perhaps you just want to simulate at one single frequency, some others over a range of frequencies. And so this gives you greater flexibility in your design. We will be talking about all the items that we've seen today in greater detail throughout the tutorials. This was just a very brief overview, and I very much look forward to showing you the capabilities of this fantastic simulator and demonstrating how it can be an incredible tool when it comes to high frequency and microwave design. Thank you.